I'm sure that all of us use numbers every day, whether you're calculating if you have enough money for your lunch, or you are counting the minutes it takes for your friend to get to the location that you planned on. Numbers are part of our life. But have you ever wondered whether numbers make up reality or numbers are part of reality? Certainly a part of our reality. So, can numbers make up reality? Let me explain this before I even look at Pythagoras, right? We can all believe, and most of us do believe, that our physical reality ultimately is made of atoms. We can't see them, can't touch them, but they're there, all right? But suppose I would ask you, could we replace those atoms with numbers? Can numbers be the stuff of which you and I are made? That's the question, because this is what Pythagoras presents us with. I find this to be one of the most bizarre theory I can explain, in the sense that all the theories I presented here in this course so far, there are good elements of them that I can use, and I can see how they are part of our world today, how they are part of science and things of that nature. But that numbers make up reality? Oh. So let me explain Pythagoras' journey that leads him to this conclusion. Pythagoras historically is understood in two ways: the man and his institute. He had a commune called a group of people called the Pythagoreans. And so the building represents that because he was so famous, his people, his students who work for him or work with him, okay, when they had discovered something, they would contribute to Pythagoras. So therefore, historians are very cautious in how they treat Pythagoras and the Pythagoreans, right? Pythagoras was the son of a merchant who traveled, a salesman who made lots of money. And in his travels, he picked up a lot of things in his studies. And Pythagoras is known as a polymath, okay? In the sense that he is knowledgeable in many areas. He's very smart, world-class genius, you can say. In the area of music, he's credited for starting the musical notation because he heard some musician playing some instrument on the street and taught the idea of the octave and began the symbolic representation of sound that ultimately becomes the musical language we have today. In mathematics, he's considered to be the first PhD because in his work, what he's doing is actually solving problems like a doctorate of mathematics would do today, a PhD in mathematics would do today. So he's actually doing research on numbers and how they work. That's what happens in his work. And in philosophy, he gives us this very I want to call it bizarre, but that's my perspective. There are still some people, intellectual with PhDs, who believe and defend this theory, okay? He gives us this grand theory that reality is made of numbers. And this is the way I think it comes about. Pythagoras had a spiritual side, okay? He didn't want to live the life of his father and make money. He wanted to, when he died, he wanted to go to heaven, the Greeks Hades, okay? In order to do that, he needed an upright life, okay? So to do that, he started spiritual commune. This wasn't arbitrary. Before he did that, he started commune. He had traveled to Egypt and joined one of the temples there. This was the bedrock of knowledge at that time. Okay, he joined one of the temple there and acquired their knowledge of the spirituality, movement of the soul, and things like that. And in Egypt at that time had the greatest amount of knowledge. Also, from everything we understand, he is now with the African folks, okay? Because Egypt, the pyramids and all of this are built by Africans. That should be common history for you right now. And then the Europeans come in, and then the Middle Eastern people come in, okay, after the original culture is basically vanished, all right? So back then, he is in African culture, all right? This is what's happening there. And they build the pyramids, they have grand knowledge and all of these different things, right? And then the city he's in gets in a war, it loses, and he has to flee for his life. And he come back to Europe and he start his spiritual commune. All right. So he's a priest already. So by the time he start his commune over here in Europe. Every commune has something you focus on to purify your being. Because he's such an intellectual, that's what I'm thinking. focus on numbers, mathematics as a means of purifying your being. I'm sure you've taken math classes before, and after it's over, I don't know if any of you felt any kind of purifying result. You may have felt relief, but did you feel purified? Okay, it's unclear, all right? But if you already have the doctrine of a soul and you think numbers are abstract entities, it's easier to say that, studying numbers is close to studying the soul. All right. So there's a mystical element. Numbers have magical properties in this period of time. Even nowadays, there's a lot of people believe in numerology. Besides studying numbers because they'll purify your soul, Pythagoras is doing real mathematics. He represents the first school, or you would say the first college of mathematics. They weren't just saying, oh, 7 is such a lucky number. Let me just think about it for the day. No. They was actually solving mathematical problem. Okay. And that's what made them popular in the city they were in. And because they could solve local people's mathematical challenges that they have, right? Geometrical problems, regular math problems, and so they became useful to the society. But they were really solving problems. That's why he's seen as the first PhD. It's not enough to be able to solve the problem, but do you know why the solution is what it is? Why does addition work? Why does multiplication work? And this is what he was doing in his school. Okay, so imagine a situation, you have people who are going to be math majors, they really love their mathematics, and they also have a spiritual side to them. In that environment, a whole different view of reality emerge. Okay. Before I go forward, some things you already know about Pythagoras. I just want to emphasize them. He discovers the Pythagorean theorem. All right, he gets credit for the Pythagorean theorem, but this formulation is something he learned in Egypt from the Africans. Okay, this is how they build the pyramid. It was just handed down knowledge. All right, if you read the history right, it's going to tell you what he gets credit for is looking at the logic behind this formula. Okay, the logic behind it. He get credit for the Pythagorean theorem, the logic behind it. That's PhD work. Okay, you can use it forever, but how does it work? And when you can, and what the Pythagorean theorem is you could take a triangle, okay, and have 3 sides, and the ABC represent each of the sides. If you have knowledge of any 2 of the sides, you can figure out what the third side is. You take the square root of a squared plus b squared, you get c, you get the length. So you get 3 lengths of any triangle, you can figure out the other. Once you develop the theorem, you can apply this in many areas, and that's not really just geometrical shapes. As long as you have the sides, you can actually apply this theorem. That's the power of the theorem that he discovered. His group, far as we know, are the first one who discovered pi, division that have infinite repetitions. Okay, somebody was dividing 22 by 7, and you get 3.14, and it kept going and going and going. Pi now is a very useful number in everything we do today. Without pi, we wouldn't even have this computer right now. Okay, so it's a very powerful number. But they discovered it, and they published on it, and they talked about it, you could say. And also, while working in their spiritual commune there, they began to do a lot of work with arithmetic and geometry. I'm not saying they invented these. They're trying to figure out how arithmetic works. They're studying geometry, measuring geometrical shapes, and things of that nature, all right? In doing so, they come to a discovery, all right? And this is the big discovery, that all physical objects can be quantified. It's like a duh to us today. Well, come on, that's no big deal. I can count the number of people in the room. I can count the number of planes in the air. I can count the number of homes on the street or on a particular block. All right. I can count. I can measure the height of a person, the weight of the person. I can quantify physical things. You take that for granted. But then they went a little further. I can think of the number 18 before the 18th person come in the room. Let's say I'm in the classroom and there's 18 students in the classroom. I could think of the 19th person that could come in just before that person comes in. And that number 19 is real. In fact, it's as real as the 18 people there. Not the person, but the number itself. 18 is real. Okay, 19 is real. They're equally real because the people there are not 18. They're a reflection of 18, but they're not 18. So 19 is equally real. And if another person comes in, I will have 19% room. So number 19 is as real as number 18. I don't need a representation for it to be real. They began to see that numbers are real, independent of the thing they quantify. This is the move that moved them forward, independent. And that led them to their view of reality. At least that's my interpretation. Because I researched, and there seemed to be, no one can explain in full how they get to this conclusion. We know the conclusion, okay? My explanation, I think, is really, really good. But they believe in this, that numbers are ultimately real. In this sense here, I mean, they're like atoms. They replace the atoms. At the deepest level, we are made of numbers, okay? That you can see that 18 or 19 is independently real of any quantification is okay, because you see numbers that has what? And oops, what has happened to my PowerPoint here? Where did I go here? Where did I go wrong? They saw numbers as abstract entities. This is a new way of looking at reality. We look at reality as stuff, and it's absolutely real. They suddenly saw that numbers are real things, but they're abstract. They're not physical. They don't have stuff. They are real. They're very, very subtle. They're real though. Numbers are real, but they don't have stuff. The atoms are stuff. And if atoms exist, numbers are real, because numbers quantify, you quantify the atoms. All right. And so they're abstract in that sense. All right. So when they did that, they postulate somehow or another that these things make up fundamental reality, in the sense that numbers are eternal and unchanging. And here's the positive insight. Given all the theories I looked at before, especially Parmenides that said there's some stuff out there. If there is one stuff out there, or there's many stuff, numbers are real. And there is arguments, there's the stuff. So numbers are real in the sense that you quantify it. Numbers are property of existence. That's the way I interpret that. Numbers are property of existence. But the Pythagoreans, because they have a strong attachment to the immortality of the soul, and the soul is also seen as abstract, and the soul exists, they put together the idea of the soul existing and it's abstract. Numbers are real and they're abstract. Numbers must also exist. And this is the challenge I have with this theory, okay? I can see where they're going. I can see that numbers as being abstract indeed, fundamental, necessary part of reality, but they are a property of existence. Not independent of existence, but a property of existence, whatever that existence is. And so in my philosophy, numbers are abstract entity, and fundamental reality doesn't consist of numbers. Numbers are part of fundamental reality because they are property of existence. But for your understanding, I need you to understand, take away this part from Pythagoras. And I have research. Maybe you can do more research. See, there's a different interpretation, different argument we discover, okay? That what he's postulating is that we, you and I, are not made of atoms, but we are made of numbers at the deeper level, all right? And even though this seems far-fetched, it's not far-fetched from how science look at this a lot, you know what I mean? When they say we're made of energy units and things like that, all right? And there are some science now going to level to saying that information is real. When they do that, they're coming right back into Pythagoras' house, all right? So in that sense, it's not completely gone. And there are people today who defend this theory. And the modern people add geometrical shape because geometries, cubes, and spheres are also abstract entities. Many people still cannot differentiate abstract entities like a number and abstract entity like a soul, okay? Like, for example, abstract entity like electricity, electromagnetic wave, or magnetic, let's look at magnetic field. A magnetic field is an abstract entity. Okay, and the magnet itself is an actual physical entity. It's not abstract at all. Okay, but when we use the abstract in this sense, the magnetic field really exists. It's just very, very subtle. Okay, unless you have, and the magnet is there, you don't have done the test with, you may not even know it's a magnet. It's very, very subtle. It's beyond your sense experiences, but on a deeper level, it does exist. The field exists. Electricity exists. So there is a sense of using the word abstract to capture things that are very, very subtle to the senses, okay? And there's a sense of using abstract in the sense that it's a property of something else that exists. And this is what I believe is the best interpretation of numbers, from my interpretation. But for Pythagoras, or if you're taking a course in philosophy, you must know this is what he thinks. And I've given you the best argument to defend that. Once he put the idea of the soul as being abstract and numbers are abstract and the soul exists because that's what he is on the deep level, then it followed that numbers also exist.